Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem LCS of three things. So before we proceed further, I would like to mention about my WhatsApp channel. So in that particular WhatsApp channel, I'm posting about off-campus opportunities, right? So it might be placement and internships. So far I've posted more than 300 off-campus opportunities, and I mainly focus on those opportunities that are not known by many, right? So I post those opportunities like after going through, I've been doing a lot of research, like visiting many career sites and then getting an idea like which batch is eligible, what are the expected salaries, etc., every detail, and then I'll be putting it in the group, so in the channel. So I'm doing a lot of research, and so far I've posted more than 250, like around 300 off-campus opportunities, and many are, there's an active community there. People are applying to those opportunities and they're using them. So make sure you also join it, because the market scenario is not that good, so it's always better to apply as many companies as possible and have a backup, right? So anyways, let us proceed further solving this question. This is a medium level question and it's the problem of the day on Geeks for Geeks today. So what is the question saying? Given three strings ABC, the task is to find the length of the longest subsequence that is common in all the three given strings. The standard problem, that is LCS, right? The longest common subsequence. The same thing here as well, just that there is another addition of string. We'll also do the another addition of dimension. So in the classical example, classical problem of LCS in the dynamic programming, we solve it using a 2D vector, right? And there is another way as also, like instead of taking a 2D vector, we can even do the space optimization. So like generalizing us, like confining to 2D vector, the similar thing we'll also be doing here, that we'll be taking a 3D vector now. Okay, so just an addition of another dimension, because we are taking three strings here, we are dealing with three strings. In that case it is just two strings, here it is three strings. That is the only difference. Okay, we are just adding in another dimension. So these are a few of the examples given, and the expected time complexity is O of n1 into n2 into n3, and space is n1 into n2 into n3. This is what we'll be doing here as well, right? So it's just 2 minutes of explanation, not more than that, that's for sure. So what we were doing in LCS, it's just that what is the brute force thing that we are doing. First we'll be taking two strings, like string S and string T, right? We'll be taking two strings and two strings. What we'll be doing, we'll be once we know this is the LCS function that will be given to us, and once we have got this particular thing, we'll be calling S T. If let us assume the length of S, okay, let us assume the length of S is X and T is Y. Okay, so this is some find function or something. Let us assume this is the find function. Okay, so X is the length of S, Y is the length of T. So what we'll be doing after this, in a find function, we'll be comparing S of X minus 1, okay, S of X minus 1, and if it is equal to, okay, if it is equal to T of Y minus 1. Okay, so we are starting from the last index. Let us assume the string is A B C D E, and this particular string is B C D E F. Okay, this is X, and this this is S, and this is T. Okay, let us assume this is this. So first we'll be comparing this two, right? If it is equal, so this is the first if condition. If it is equal, okay, if it is equal, then we will return, like we'll return the answer like 1 plus. Okay, 1 plus, we'll be calling the find function on S T X minus 1 and Y minus 1. Okay, so we'll be calling, because one character we have already compared, so we'll just move these two pointers simultaneously to the left. Okay, because we have already compared and we have found that these both are equal. Now in this case both are not equal, E is not equal to F, that I know. But if it is equal, like instead of F it is E, or instead of E it is F, then we'll be calling this function 1 plus find of ST X minus 1. If it is not equal, like in our case right now, if it is not equal, then what we'll be doing, so max of, so either we'll be moving this pointer to this side and compare this whole string with BCDE, or we'll be taking this E to this side and we'll be comparing the whole string with BCDF, isn't it? So max of find of ST, either you'll be decreasing X and you'll be putting Y to be same, or find of ST X Y minus 1, right? This is what you'll be doing, and finally you'll be returning that particular answer, return answer. Okay, return answer, whatever you have got here answer equal to or answer equal to and return that particular answer, isn't it? This is the blueprint, or what do you say, the pseudocode of the technique that we do, the brute force technique. And because we are doing multiple sub problems, we are solving multiple sub problems, same sub problem multiple times. Okay, we are doing that. So if you can just realize it, if you just do it right, and it's very easy. I do not need to tell all these things. We have been doing all these things so far, right? Many times. So if we go with this brute force, we'll be doing the same sub problem, solving the same sub problem multiple times. So we take a 2D vector, right? 2D vector, 2D vector, 2D vector dp, like whose status like dp of ij. So where I denotes the length of string s, j denotes the length of string t. So we'll be storing it. So similar thing, dp of ij would be, dp of ij would be equal to dp of 1 plus dp of I minus 1 j minus 1. If in case equal case, right? Equal case, equal case. If not equal, dp of ij equals to max of dp of I minus 1 j or dp of ij minus 1, right? This is what we'll be doing if it is not equal, right? Not equal. And finally we'll be returning the dp of mn or xy, okay, xy. So whatever you could say, like dp of return of xy means, because we'll be calling the first find function, right? First find function directly will be going here. So first, if you call the first find function, we'll be giving these two as the parameter, right? X and y. So what do we mean by the dp state? Dp of xy gives us the length of the longest common substring, longest common subsequence between the string s and t. Okay, longest common subsequence between s and t. So finally we'll be returning this answer. I hope I'm getting it. So here also, like, you'll be like this will be putting as for loop. Okay, this will be putting as for loop, like the bottom up approach that I'm talking about. So instead of bottom up approach, you can even do this like calling on recursion. You can even do this on like calling recursion. So like you'll be storing that result. First you'll be checking if dp of ij not equal to xy not equal to -1. Okay, you'll be first checking it. If it's not equal to -1, then you'll be returning it. Nor you'll be calling this on xy equals to 1 plus find of st x minus 1 y minus 1 if it's equal, or dp of xy would be maximum of x minus 1 y comma dp of x y minus 1, right? And then you'll be finally returning dp of xy if it's like memoization that you're doing. But if it's a if it's a bottom up approach, you'll be using a for loop, isn't it? You'll be using a for loop and you'll be solving this. So this is a basic LCS that we have already doing. We have been we know the brute force, we know the memoization technique, we know the bottom up approach. The same thing we are replicating here as well. Okay, so if we just go through the code here, so the same thing we are replicating here, just that we are adding in another dimension. So this is like bottom up approach. So this is the bottom up approach. So what are we doing here? The same thing. If you could go through the LCS code of, if you know that LCS code, first write the LCS code for two strings, okay, then put in another dimension. That's it. It will be very easy for you people, right? And another loop as well. Okay, so first we'll be taking a 3D vector into dp of n plus 1, n plus 2, and 3 plus 1. Okay, so 3 dimensions, and then for int I equal to 0, I less than or n1 I plus plus, j less than or equal to n2 j plus plus, k less than or equal to n3 k plus plus. So if in case any of them are equal to 0, like I equal to 0, j equal to 0, k equal to 0, then the longest subsequence that is common to both of all of them is 0 itself, because one of them is 0. So no matter, you'll be able to get a longest subsequence, that common subsequence that is greater than 0, right? Because one of them is 0 here. And else, if a minus 1 equal to bj minus 1 and a minus 1 equal to ck minus 1, that means we are comparing the character at ijk. Okay, we are comparing the character at ijk. And in case a's at I minus 1 index character is equal to b's at j minus 1 index, and it c's k minus 1 k minus 1 index, so in that case all of them are matching, then we'll be adding 1. Okay, because we are finding longest common subsequence. So we have found one common character among all those three. So we'll be adding 1 plus dp of I minus 1, j minus 1, k minus 1. Now we are reducing our length, isn't it? So that is the case. Or else dp of ijk equal to max of dp of I minus 1 jk, dp of ij minus 1 k, dp of ij k minus 1, isn't it? The similar thing that we have done in LCS. So ij minus 1 or I minus 1 j, like reduce the length of the first string keeping the length of the second string to be same, or reduce the length of the second string keeping the first length to be same. Similarly we are doing here, this is first length reduction, the first one, the first length, the first this thing, first length reduction, this is second length reduction, and this is third length reduction. Okay, so the same thing that we've been doing. Okay, yeah, so that's it. And finally written dp of n1 n2 n3, right? This is the length. So dp of n1 n2 n3 gives us the final. So by the length of like string a of length n1, b of length n2, c of length n3, what is the longest common subsequence that we have got, right? So that is what we'll be writing at the end of the day. I hope you people have understood. It's pretty easy, just the extension. Okay, just an extra for loop, just an extra dimension that you're going to add to your dp, nothing else. Everything is pretty straightforward. So my advice for you people to solve this question is, first assume that this question is for LCS of two strings, and write the code. Okay, this bottom up approach code that you'll be doing, or you can start from brute force and then memorize it and then write the brute force, I mean sorry, bottom up, and then put an extra extension, I mean extra dimension like n3 plus 1. This is what you'll be putting as extra, and also put an extra for loop. That's it, nothing else. Everything remains the same. Okay, so I hope you people have understood this. If you let me know if you want brute force and memoization codes for these this particular problem, LCS of three things, I'll even be happy to put that in the comment section, right? So that's it, guys. Thank you for watching this video. Make sure to join the WhatsApp community. That will be so good for you people. It will be really helpful. So no matter what, when it is whatever it is the time, we need to have some backup. So keep applying to as many companies as possible. It will eventually help you a lot, right? So that's it, guys. And also for your reference, C++, Java, Python codes are there in the description. Please go through them. And thank you for watching. Stay tuned.